Welcome to a lecture series on digital image processing practicals in the NV image processing platform. So in these practicals, we are now, it is a continuation of the spectral subset practical. We have done spectral subset. There is a separate movie on this. You please have a look at the separate subset of spectra. Once if you do subset of spectral basis classification, say for example, water body is classified. And sometimes what will happen, the same reflectance with respect to the water body on the other regions with a single pixel or double pixel, error will come during that, and then that has to be removed. This is called spatial subset. So there is a tool is being used exclusively for operating this to remove the noises or the unwanted classified pixels, small pixels. So in this practical now we are going to see about that, how to apply the spatial filter for the, once if you open and the NV platform, the window will come. Now we will have to open the already subsetted spectra. Once if the the spectra, it is in the name of BIR MS water dot. So we have done the classification of the water body. So this is the classified water body, and you just have a look at it. This is very clear that this is water body, but small pixels, the same reflectance on the other sides are also coming. So that has to be rectified, and that has to be removed. So this is very clear, and you see this is not the water body will not look like this, and it is known to us. So this has to be removed. How to remove this? You have to go to a filter, and in the filter convolution morphology you have to select and then double click. Once if you double click the convolution and morphology tool, a tool will come, and already there is a road in morphology. You apply a road, and you have to take size of the movement. Spatial filtering theory part, if you read, you'll be able to know. So you are now giving the input file, and then after giving the input file and all the details, like that other details, like if you have kept any memory, you can kept if you want to save also, you can do. Now you see this is spatial filtering output. So the spatial filtering output is very clear. It is coming out with only the water body. The other regions are excluded. And similarly, you can apply many things like erode, dilate, and the convolution also, high pass filter, low pass filter, Laplacian filter, directional filter, and Gaussian high pass, low pass, median. So, well, once if you use this and operate with different images and read the basic theory, then we will be able to assess that how best the spatial filtering is useful to our study, or to understand how that this has to be done. Okay, this is how the morphological, spatial filtering, so that it is cluster of the spectra is taken out, or with the kernel size also you can take 3 by 3. Normally we move the pixel 3 by 3 over the entire images, and then once what will happen, this will move with this number into the spectra, and automatically it will delete the lower numbers, and it will keep the continuous higher numbers. So if 3 pixel by 3 pixel carries the water body, then it will keep as such. Otherwise it will remove. If the pixel come here, if the pixel come here, if the pixel come here, you can also do with your own customized cell size also. This is called kernel size movement. That the in-depth knowledge for the practicals on assessing this, you just take it from the theory part. Okay, so it's very simple. Normally we use 3 by 3 kernel, and then the theory part, it is that if we move the kernels, what automatically and the spectrum on the other regions will we have to move like this. So from this part to this part, and then the pixel, it is automatic. So once if you move, automatically this will come. So this is Laplacian. If you take this is the already set algorithms like 0, 1, and You can also user defined, you can keep only 4 here, or you can remove 0 on the other side also. So this is how we can play with and basic theory part, plus apply this, and you see you have many things like FFT, forward inverse filter, gamma filter, gown filter, leaf filter, and many things are there. All these things are spatial filtering operations. I have shown only one 3 by 3 kernel movement of removing the unwanted noises or the small pixels outside the major pixels. So with this, the discussion on spatial filtering is come to an end. Thank you very much.